about naming this molecule? Well, first of all, we want to look at the main chain, the longest continuous carbon chain. Here, the longest chain is 8 carbons long, so the main chain name is octane. Next, we want to consider the location of the functional groups attached to the main chain. We can number from left to right, in which case positions 2, 5, 6, and 7 have functional groups attached, or we can number from right to left, and now those positions are 2, 3, 4, and 7. We look to the lowest number. In both directions, that's 2, so we don't get any information there. So we need to look to the next lowest number and see if there's a difference there. Well, now it's 3 versus 5. 3 is lower than 5, so we're going to number from right to left. Next, we want to give names to the functional groups and place them in alphabetical order. There's something new going on here. We have a complex alkane that's attached to the main chain. It's isopropyl. It's not a simple zigzag shape. When we're looking at isogroups, for example, isopropyl or isobutyl, we start the alphabetical calculation with I. So isopropyl or isobutyl come before methyl. This is also true of neo-substituents. For example, neobutyl, we'd start the calculation with the letter N. But other substituents like sec or tert, for example, sec-butyl or tert-butyl, well, here we ignore the S and the T and start the calculation with B for butyl. Okay, what about those functional group names? We have 2-chloro, 3-methyl, 4-isopropyl, and 7-iodo, but that's not in alphabetical order. So the final name is 2-chloro, 7-iodo, 4-isopropyl, 3-methyl, octane. So remember, when you're dealing with complex alkanes that are attached to your main chain, so not the simple zigzag shape, if there's an established name, for example, iso, sec, tert, or neo, use it. If your molecule doesn't fit within those names, you're going to need to name that section of the molecule as if it's its own separate molecule, and then you place that name within the whole name.